students. On this clip, we're going to be going over 3 examples on the properties of logarithms. We're going to talk about the properties first. I'm going to go over 4 properties I'm going to be using to do these examples, and then we'll go ahead and do the examples. All right, so let's start out by writing down some of the properties, okay? So the first one we'll look at is the product property. Okay, so what is the product property for logarithms? If you have log base b of x times y, it can be rewritten as log base b of x plus log base b of y. Okay, so if you have the product of 2 numbers, you can just translate it into the sum of their independent logarithms. All right, and then the next formula is a quotient. The next property, sorry, is a quotient property. So if you have a quotient of 2 terms, base b, so log base b of x over y, if you have this quotient, it can be written as log base b of x minus log base b of y. Okay? Alright, and then the next one we'll look at is the power property. Okay? The power property. Now, what will you do if you have a power, the logarithm of a power? Power is straight power. What do you do if you have the logarithm of a power? So let's say you have log base b of a raised to the nth power. What do you do in that case? Well, it can be rewritten as n log base b of a. Okay? So basically, this power comes to the front. It's just a consequence of repeated addition. If you have a to the n, you're going to have a times a n times, which translates into a plus a using this formula, and then that's basically n times log base log a base b. Okay, so you're going to have n of these, and then you just combine it into this formula right here. So it's, multiplication is repeated addition, right? So if you're adding log a base b n number of times, it's the same thing as n times log base b of a. Okay? All right, number 4 is the inverse property. The inverse property. Now, what do you have if you have log base b of b? Well, that's simply 1. Okay? The reason being that the power of b is 1 here, and these 2 operations are inverses, so they cancel each other out, and you're just left with 1. All right? So these are the properties I want you to keep in mind for the examples. Okay? Okay. Now let's go ahead and try out some examples. Let's write down instructions for the examples first. So basically, use log of 4 base 5, which is approximately 0.8614, and log of 9 base 5, which is approximately 1.3652, to approximate the value of each expression. Okay, to approximate the value of each expression. Okay. All right. So let's start out with the first one, question number 1. What if we have log base 5 of 36? Log base 5 of 36. Now, one thing I want you to note is that you have log base 5 of 4 and log base 5 of 9. There's an additional log that you know that will not be provided, but you're soon to know it, okay? And that is basically the fact that log base 5 of 5 is equal to, think about the inverse property. These two are inverses, so they cancel each other out and they become 1 because the power here is 1, okay? So when the base and the value match, what you're taking a logarithm of match, they cancel each other out. because you're inverses, and whatever the exponent of this number is, that's what you're going to have. Okay, so just keep that in mind. You also know this fact. Now, to solve this, we have to express 36 using the combination of 4, 9, and 5. If there's any way we can multiply and divide 4, 9, and 5 to generate 36, that will be our answer. Okay, so let's see how can we do this. If we break down 36 using 4, we have a 4 here. If I take out 4 from 36, I'll be left with 9, which is excellent because I know log of 4 base 5 and I know log of 9 base 5. So all I'll need to do is rewrite this using the logs that I know, and then I'll make a substitution. Okay, so this becomes log base 5 of what? 9 times 4. Okay, now we're going to use the product property of logarithm, which states that the product of the values you're taking a log of can be written as a product, as a sum of the logs. So the times is going to become a sum. All right, so you're going to have log base 5 of 9 plus log base 5 of 4. Okay, now I'm going to substitute these with the approximate values and then compute the sum. So this is going to be approximately log base 5 of 9 is 1.3652, and then log base 5 of 4 is 0.8614. Okay, so we just add these up using our calculators, and that will be the answer. All right, so we're going to go 1.3652 plus 0.8614. Answer is 2.2266. Okay, so that's the answer, 2.2266. So our final answer is approximately 2.2266. Okay. All right, let's move on to question number 2. Question 2, we're going to consider the expression, we're going to look for log base 5 of 9 over 20. Okay? All right, now remember, we have to express these terms using a combination of 4, 5, and 9. Okay? So how can we express this using 4, 5, and 9? The numerator is already 9, which is excellent. How about the denominator? Can I express the denominator using the product, power of any of these combination? Well, let's put 20 to the side, and we're going to break it down. I can take out 4, since I have 4 there. I know 4 goes into 20. 4 goes into 25 times. All right, so that's exactly what I want. I have 4 and 5. I have 4 and 5, so I'm going to rewrite this term right here that I'm taking a logarithm of using these 3 numbers. So I'm going to write this as log base 5 of 9 divided by 5 times 4. Okay? All right. Now, I'm going to make application of the product and quotient properties of logarithms one at a time. Okay, so first of all, we're going to apply the quotient property anytime you're dividing. Remember, when you're dividing, it's as though you were subtracting the logarithm. So this is going to become log base 5 of 9 minus log base 5 of 5 times 4. Okay, so we're subtracting this log from this log right here. All right, now I'm going to break this further. We have a product here, so we can use the product property of logarithms. So I'm going to write this as log base 5 of 9 minus, since this is going to become 2 expressions, I'm going to put parentheses, actually 2 terms, log base 5 of 5 plus log base 5 of 4. All right, so this product right here became a sum. So now what I'm going to do is I'm going to distribute this negative to both terms. So this becomes log base 5 of 9 minus log base 5 of 5 minus this time becomes a minus log base 5 of 4. Okay? You notice how I distributed this minus to this minus, to this plus, it changed the plus to a minus, alright? So now what I'm going to do is, I'm now ready to substitute these with the approximate logarithmic values and then compute the difference, alright? So this is approximately, log base 5 of 9 is approximately 1.3652. Log base 5 of 5 using the inverse property of logarithms is 1, minus log base 5. Log base 5 of 4 is 0.8614. Alright? So we're just going to use our calculators to evaluate this combination of terms using the properties of order of operations. So we're going to do 1.3652 minus 1 minus 0.8614. Alright, and the answer is negative 4962, negative 0.4962. So this is approximately negative 0.4962. Okay, so there you have it. Alright, let's move on to question number 3. So for question 3, we want to find the value of log base 5 of the expression 3 over 5. Okay? So we want to express these two terms as a product or quotient of a combination of 4, 9, and 5. So we already have 5 on the denominator. That's excellent. But this 3 here is a problem. Okay? So can I raise 4, 9, or 5 to any power to get 3? Well, let's take a look at 9. What power can I raise 9 to get 3? Is there any power I can raise 9 to get 3? Absolutely. 9 to the 1/2 power is the same thing as the square root of 9, which is equal to 3. Okay? So I'm going to rewrite this expression as log base 5 of 9 to the 1/2 divided by 5. Now I have the term that I'm taking the logarithm of, expressed using a combination of the values that I know the logarithmic approximate of. Okay? So now we're going to use the property of logarithm, namely the quotient property, to write this as log base 5 of 9.5 minus log base 5 of 5. Alright, now if you take a look at the first term, I know what log base 5 of 9 is. I don't know what log base 5 of 9 to the 1/2 is, so I need to resolve this. How do I deal with this power? Well, I'll use the power property of logarithm to deal with this term here. So what I'll do is this 1/2 can come to the front as a product right here. So it becomes 1/2 log base 5 of 9 minus log base 5 of 5. Okay? Now I know what log base 5 of 9 is, right? It's 1.3625. So I'm going to have 1/2 times 1.3652 minus 1. Because using the, well, I already know here, using the inverse property of logarithms, I know that this is 1. Alright? So we can just simply plug in this expression into our calculators and have it compute the difference for us, okay? So we're going to have 1/2 in parentheses. Please put your 1/2 in parentheses. 1/2 times 1.3652 minus 1, okay? And the answer is negative 3174. Negative 0.3174, okay? So there goes your final result. Well, thanks so much for watching this video. Please feel free to subscribe to my channel by clicking up here. More videos can be found on mypru3l2b.com. Thanks again and have a wonderful day.